everyone. So in this session we will deal about half-wave and full-wave rectifier. Do you know how to design a half-wave and full-wave rectifier? That is a rectifier. By which components you can design a rectifier? The main component is PN Junction diode. Okay. What are the application of PN Junction diode? Do you have any idea? Just give me some answers. Okay. See here, main application of PN Junction diode is rectifier. Okay. So here we are going to construct a rectifier. So normally this is the transformer. So what is the purpose of transformer here is in the here we are stepping down the voltage because the diode cannot withstand the direct to 30 volt. Okay. So we are using a step down transformer and we are connecting to the diode which we are connecting to the cathode of a diode. Okay, it will be in forward bias, cathode of a diode, and we are connecting a resistor load. For a load we are using a resistor. So then we will connect, for viewing the output we will connect it to the CR. Here in half-wave rectifier we will get the pulsating output. We will not get pure DC. In order to get pure DC we have to go for a capacitor, that is filter. So in place of filter we will go with capacitor. Okay. What happens here is you will get the pulsating DC output. So I am just adjusting. Here only the negative cycle gets rectified. You will get the output, you will get the sine waveform for your positive cycle, and for your negative cycle it gets ripple, because in negative cycle your diode will be reverse bias. Whether the diode will work in reverse bias? No, the diode does not work in reverse bias. So that's the reason it gets does not get any output. Okay. So when we are adding a capacitor, it just gets filtered. Okay, that's the thing. So that's all with the half-wave rectifier. Where we will connect the capacitor here is we will connect parallel to the load. Okay, we will just connect it parallel to the load, that is parallel to the resistor. So our output can get filtered. Okay. When coming to the efficiency of half-wave rectifier is 40%. Okay, and the ripple factor will be 1.21. The ripple factor in the sense ripples is disturbance. Okay, so there will be many disturbance in half-wave rectifier, and efficiency is also very low. So that's the reason we are going for full-wave rectifier. In full-wave rectifier, we will only say we'll use same diode, but we'll use two diodes. For example, in positive half cycle, one diode will work, and in negative half cycle, the other diode will work. Okay, the construction wise it will be same. That is, we'll connect a load for a resistor. We'll make it as the same, and the output waveform for half-wave rectifier will be I will get for output for the two cycles also. We'll see how we are getting the output, and the efficiency for full-wave rectifier will be around 80%. Okay, you'll have to get 80% output voltage, and the ripple factor will be 0.48. Okay. When you are switching on the supply, you will get the output waveform like this. Okay. I think you know this is cathode ray oscilloscope, and you can adjust the positions like this. Y-axis position like this, and x-axis position here you can adjust. Okay. You can adjust when you are taking the reading. You can just adjust this. And how we will take the reading here is this. Always take the y-axis as the voltage and x-axis as the current. Time period. Okay, x-axis is time period, not current. Y-axis is the voltage, x-axis is time period. Okay, now it's like just consider this as a graph sheet. So how many, this is volt per division. How many volts per division here is 10. So when it is 10 voltage, it gets compressed. For example, see this is 5. The 5 voltage, it is how many division it takes? 1, 2, 3. 3.4 divisions, right? So it's taking 3.4 divisions for voltage. For 1 division it is 5. For 3.4 into 5. That is your voltage. Okay. Time period you have to measure for one positive cycle and negative cycle. So we'll come for the full-wave rectifier. So what happened here is for positive half cycle you are getting the output. For negative cycle also you are getting the output, because for a positive cycle, for example, you have D1 and D2. D1 will work, and for negative half cycle, D2 will work. Okay. So now what happens here is when you are adding the filter, where you add the filter, that is capacitor parallel to the load. Okay, we'll add parallel to the load. So what happens? This, right? So your output will be rectified. This is not pure DC. This is pulsating DC. It is a pulsating one. So when we need pure DC, we have to go for capacitor. Okay, you have any doubt? That's all with the half wave and full wave rectifier. Just make sure we are using efficient one. Okay, we have another rectifier, that is, we will call it as bridge rectifier. That is the advanced version of the full wave rectifier. The transformer utilization factor will be good for bridge rectifier when compared to the full wave rectifier. Okay, so that's all with this. Thank you.